Lindsay, what are you doing?
So, just like us, trees can connect with one another, they can reproduce, they can protect themselves, they help each other out, and sometimes they even find themselves in competition with other trees. How they do this is through a symbiotic relationship. What I mean by that is just that both parties of that relationship get what they need out of it. This relationship is between trees and fungus within the soil. This fungus creates kind of like a network. So if you think of humans as having the internet, we use the internet to connect to one another all the time. We have communities, so we have neighbors, we have friends, we have coworkers, we have lots of people that we're connecting with all the time. We're sharing information, we're sharing resources. So for example, if somebody's in need, we actually can donate food to the food bank, and then other people can go and get that food from the food bank. Just like us, this network creates a way for trees to communicate. So if one tree is struggling, then other trees can be sent a signal and send nutrients that that tree needs in order to keep going or keep growing, or in order to thrive. So just in this clump of dirt and organic materials that I pulled up, you can see that lots of these little root systems and things are connected. This is an example of that network that I'm talking about. So this fungus and these roots are all connected, therefore allowing those trees connect to one another. Again, just like us, trees have certain ways in which they protect themselves. For example, we have skin. Skin protects us from outside bacteria, even bugs, which is kind of gross to think about. Our skin is basically there to help protect us from infection. This birch tree, for example, has an outside skin, if you will, just like other trees, so their bark is their skin. This birch tree, though, has a kind of neat trick that it does. This trick involves, one, shedding old bark that is now too small for the tree as it gets larger and larger, but by allowing this bark to kind of hang off the tree, it attracts bugs or bacteria to the bark that's actually hanging off instead of onto the actual bark that's protecting the tree currently. As you're like walking through the woods, or if you want to make a fire, we know that birch bark is pretty good for fires. Peeling this stuff off actually is bad for the trees. If you see this stuff in the woods, make sure to just leave it where it is. This here is a burl. It's like a tree scab. Something happened to this tree. Either an insect got in there and made a hole, infected this whole bit of this tree. Maybe a tree could get struck by lightning, or there was a deer rub that took off the outside layer of this bark. What the tree does is like, oh, there's a problem. I'm now exposed to the elements, so I need to fix it. Just like us, when we get a scrape or a scratch, what our bodies do is it creates a scab over top of it. What that allows is for that cut or that scrape to not become infected. So this tree kind of changed its chemistry. It sent this signal to the infected area to cover it up. These burls aren't actually straight up and down like the tree is currently. It's actually a bunch of mixed up all kinds of directions in order to cover up that opening. This tree's trunk is in charge of sending the nutrients that the roots absorb up to the leaves, where that photosynthesis process happens. It's a big word. That process, so that transfer of nutrients, still actually happens within this burl. But instead of it going straight up now, it's actually going through all of these kind of twisted tunnels, if you will. And it still makes it up to the leaves where it needs to be. Wow, nature's so neat. This tree has been affected by what looks like a woodpecker. So a woodpecker would have started pecking away at this tree, looking to get the sap out so the sap could actually attract bugs. The holes in this tree, though, can affect the tree in a lot of different ways. So one of them can be that it exposes it to bacteria, but by attracting bugs, it could be attracting bugs that aren't good for this tree. This tree, probably in its early stages of being infected or being pecked into by the woodpecker, would have gotten some kind of message or received a message through that fungal network that I was talking about earlier. If a tree in its community was also being pecked on by a woodpecker, it would have sent a signal saying, hey, danger, there's a woodpecker in the area. And what these trees can actually do is they can send out a chemical through that root system in order to say, like, hey, be aware of this. And then the tree can actually change its chemistry in order to deter that bug or that predator, like the woodpecker, away from the tree itself. It does take quite a while. Like, you can't just holler and scream as a tree and be like, hey, danger, danger. It takes quite a few hours in order for that message to be sent to other trees. The other way trees can tell other trees in its community about danger is through scent. So they can actually send off pheromones, which is just a scent, to other trees, warning it of that danger. Not only do trees need to protect themselves from bugs and other predators like deer or other animals eating them, they also need to protect themselves from weather. So winter's a huge one. Deciduous and coniferous trees do it a little bit differently. Coniferous trees hold on to their needles all year round. The reason they're able to do that is because their sap is super thick. Their sap actually has a lower freezing point. When coniferous trees go through the winter, they can actually photosynthesize all year round, allowing them to create the sugars and that nutrients that they need in order to survive. Deciduous trees in the wintertime can't actually hold on to their leaves. The reason for that is because their leaves are more widespread, they're wider, and they actually contain more water. When water freezes, it actually expands. What happens is it actually breaks the cells down in the leaves themselves. That would not be good for the tree. Therefore, what they've learned to do is actually drop their leaves in the fall before the temperature gets below freezing. They actually send a lot of their water content, so that sugary liquid, into the main trunk or into the roots of the actual tree. By doing that, they're saving those upper branches and the leaves from pretty much bursting open. The sugar content in these trees, or the sap, let's think of like sugar maples for a second. Sugar maples have sap in them, we know that because that's where maple syrup comes from, but that sap is less thick than coniferous trees that we were just talking about. In order to reproduce, trees need to have their flowers pollinated. Some trees will have both female and male parts right within their flower, so pollen is transferred that way with the wind or with animals transferring that pollen. Some trees have male trees or female trees. Once those flowers are pollinated, seeds are created, and then those seeds need to be dispersed so that new saplings can grow. Seeds can be dispersed one of 5 ways. Seeds can be dispersed through wind, water, animals, through gravity, and through what's like an explosion type of dispersal. So I'm going to talk mainly about water, wind, gravity, and animals, but the explosion one's pretty cool if you want to look it up later. Here I have what are called maple keys. So maple trees use the wind to disperse their seeds. These maple keys are pretty neat because once they get dropped, the wind will carry them and they kind of flutter. If you ever do find a fresh maple key, toss it in the air and you can watch it kind of do its little spinny move there, and it actually disperses the seeds that way. So any of these maple keys, once dropped, won't land right underneath the tree. That wouldn't be very good for it, but it will spread out, and the windier it is, the better. Maple trees are an example of a tree that uses the wind to disperse its seeds. Another seed that I have here is pine cone. So pine trees have cones, spruce trees have cones, lots of firs. And how they spread their seeds is they actually use gravity. So they'll drop it and it'll land wherever it's gonna land. Lots of the time, it might stay there. More likely, an animal's gonna get to it, it's gonna eat those seeds that are in that pine cone, and they're actually gonna wander off, do their own thing, and then poop it out somewhere else. So gravity is one way, okay? So it lands on the ground, it gets buried, and grows a new tree there, or an animal spreads it for it. Another example of one that uses gravity and animals is this one here. This is an acorn, so from an oak tree. Same thing, it gets dropped on the ground, it can grow a little sapling right there, or more likely, squirrels in particular, are gonna carry this. They're gonna maybe hide it away in a hole somewhere. Maybe it'll get forgotten and then it'll grow there, or it'll be deposited somewhere else through that animal's scat. A good example of a tree that uses the water to spread its seeds is a willow tree, so you might even see them around your neighborhood. Those trees, when they drop their seeds into water or stream, they get carried down the riverbank and planted into the side of the river. Lots of times you'll see willows along riverbeds or streams. This is a beech tree. I can tell by the way it is. Just kidding. The beech tree's bark is very specific, so it looks like elephant skin. It's very smooth and it has that like gray, sleek kind of look to it. Beech trees, just like every other tree out there, love each other, right? They need to reproduce, but they don't necessarily show love the same way humans do. They can't make their partner dinner or give them a big hug, right? But they do need to drop seeds in order for them to grow new beech trees. Their goal, like every other tree or plant in the forest, is to reproduce and keep that species going. Beech trees and a couple other species in the forest of trees, they have this cool trick. So they'll drop, beech trees in particular drop beech nuts. They'll drop a certain amount of seeds every year, but then every 7 to 10 years or so, they'll drop way more than normal. The reason they do this is because they know that they have natural predators. So squirrels and deer will eat these beech nuts every year, right? And squirrels and deer are pretty smart. They know that these beech trees are here. They know that these beech trees want to reproduce, so they'll drop the beech nuts, and then the squirrels and deer will just come and eat them all. For this sapling in particular, if squirrels and deer are coming to eat all those nuts, this sapling probably wouldn't have a very good chance of actually surviving. What this beech tree does, by dropping several beech nuts every 7 to 10 years or so, they're actually making it so that the deer and squirrels can't eat them all. That allows those beech nuts to actually be planted in the ground and for these new saplings to come up. Isn't that neat? Some trees in the forest are friends, right? They're connecting through that fungal network that we were talking about. So they can send nutrients regardless of the species they are. So birch and fir, for example, will share nutrients if need be. But there are some trees in the forest that are actually competing for resources. The resources being sunlight, water, nutrients, that carbon. They need all of those things in order to survive. But some species are good at sharing, and then some species are not. So this tree here is actually a spruce tree, and if you notice, there's actually a huge ash tree right here. So in the summertime, it'll have tons of leaves on it, which will actually be shadowing this spruce tree. To the other side, there's actually another large tree. I'm not sure exactly what type of tree it is, but again, it's a deciduous tree, so in the summertime, it's gonna have lots of leaves on it that will be, again, shadowing this tree. In behind, there's a pine tree that will block it from the sun as well. So there's 3 trees on 3 sides of this spruce tree that are going to be taking away the sunlight from that tree. Coniferous trees, though, are kind of cool. They have this neat trick that they do, that if they're not getting enough sunlight, they can actually kill off their bottom branches in order to send nutrients and water to the leaves at the top of the tree, where they have better chances of actually getting sunlight. So these branches here at the bottom of the tree are actually all dead. There's no energy going into these branches at all. Me breaking these branches off don't actually hurt the tree that much. If I were to start breaking branches off the top of the tree where there are actually green needles, that would be detrimental to the tree, because that's where all the photosynthesis, that big word again, is actually happening, right? That sunlight's being absorbed, the carbon dioxide's being absorbed, water's being used, and food is being made for the tree up there where it's actually getting the sunlight. So here we have some cedar trees. These trees have a really cool way of competing with other trees, and the way they do that is they actually send a chemical through their root system, so again, that fungal network that says to other plants and stuff, this is not a good spot for you to grow. Those other plants and maybe even some other trees don't actually like that chemical. So I'll show you in here in just a second. There's actually not a lot growing in this area. There are a couple little trilliums and maybe some maple saplings that made their way in here. Overall, it's just kind of dead brush or organic materials that are laying on the forest floor here. There's not a lot of other vegetation growing. How neat is that? This connection between trees wouldn't be possible without hub trees or mother trees, as they like to call it. So this tree here is probably a pretty good example of a mother tree. Mother trees are those trees that have been around for hundreds and hundreds of years. So they've given way to many other saplings of the same species. What they also do is they actually have the most connections within the forest. So using that fungal network, they're connecting with all of their years of saplings, but also with other types of trees. If for some reason these hub trees or these mother trees were cut down, those connections would become much smaller and the forest probably wouldn't do as well. Because these trees have been around for so long, they've actually been able to adapt and change their DNA because they've been through hot years, cold years, they've lived through bug infestations, they've experienced all kinds of bacterial infections. Because they're able to change their DNA, they can prepare themselves to deal with those things in the future. With that said, when they drop new seeds, they actually are preparing their own saplings to deal with those struggles or those problems in the future.